Good morning, everybody. Welcome to Tuesday's plenary. My name is Melissa, and I just have a few announcements for you before we start all the talks on the Discovery Alliance. We'll hear from lightning stories, and then we'll do some student flash talks at the end. Start with the usual reminders that we have a code of conduct, and if you witness or experience any violations of that, there are contacts for the code of conduct that you should please email to let them know what happened. Also keep an eye out for those social battery pins and just sort of be respectful of how other people are feeling. If you're with us from Zoom, please remain muted. We will ask you to unmute if you have questions to be asked. And also a reminder that the Slack space is another place where you can go to ask questions. There's a channel for every single session, and you can go there and have discussions. And we can also raise questions in the room if you're a virtual participant who has asked them in Slack. A reminder that coffee breaks happen in 3 locations, which you've probably found by now. Another reminder too, actually, that Redwood is not ours this morning. So nothing is happening in Redwood this morning. And if you are joining us, if you're hearing me, you've already found a place to watch this plenary, but Redwood is not a remote plenary watching site this morning. Instead, the Kavli 3rd floor conference room is the other spot to watch this plenary from. Posters. This is day 2 of our Monday and Tuesday poster session. It's the afternoon breaks that are designated as the poster session where the students will be there by their posters, standing next to their boards, waiting to talk to you. And as a reminder too, there is a virtual posters option. This option isn't just for virtual attendees, it's for anyone who wants to share anything virtually. So if you have an in-person poster and you want to also post it as a virtual poster so that virtual attendees of the RCW can see it, you just go and follow these instructions and post it as a Rubin Research Bite. If you gave a talk, you could also post a short version of your slides, pretty much anything you want. You just keep it short and post your Rubin Research Bite. Reminder that today is group photo day. The photo will be taken at the Slack fountain at 5:30 p.m. So just show up promptly, wear your t-shirt if you have one, if you want to, and just follow the instructions to get in place and we'll do the picture. If you're a virtual attendee, please send us a picture of you. Just drop it in at ls.sc/share so we can include it in the photo. Tonight is our reception, Tuesday, 6 p.m. at the Slack Cafe. It is over in building 53. It's an indoor-outdoor reception. There will be heavy appetizers, and the cost was included in your registration fee. If you want to bring a guest, it's $50, and you can talk to the folks at the registration table about that. For lunches, there's a lunch information page. I heard that getting lunch was a bit of a challenge yesterday with things getting really busy. So today there are some new convenient lunch options. One will be a delivery, a complimentary sandwich delivery. It doesn't say the name of the place on here, but it's Eric's Gourmet Sandwiches. It's all like cold sandwiches. So you can go to this QR code, put in your order between 10 and 11 a.m. Heather is going to pick up everybody's orders and bring them back to the registration desk. So when you do put in your order, you do have to select in-store pickup. You have to say it's for 11 a.m. because that's when Heather's going to go get them. Check out as guest. Don't need to make an account. But for your first name, you have to put in Slack RCW delivery because Heather is going to be given all of the sandwiches with that first name to be brought back over here. And then for last name, phone, and email, just use your own stuff. So this slide is also, it's in the plenary deck that's uploaded to the web page for today's morning plenary. So you can go back and find these. But those are the instructions if you want in on the sandwich order. And then there's also an app where you can order ahead at the Slack Cafe and just pick it up. So that's some new lunch stuff going on. And then just to back up and remind you that Trinity remains our social lunchroom. And today, tomorrow, and Thursday, it's all EPO sessions. So they will have content for you, things you can learn about EPO in Trinity during your lunchtime. Final reminder, Unconference is on Wednesday, so be sure to visit the board that's in the registration area over in building 53. And as another reminder, all speakers and chairs, please be in your rooms 15 minutes early for the AV checks. With that, we're going to switch over to Discovery Alliance.
Good morning. I'm Michael Woodvasey. I'm a professor of physics and astronomy at the University of Pittsburgh. I come to you as the chair of the board for the LSST Discovery Alliance today. So the history of the LSST Discovery Alliance is somewhat long, younger than I am, but uh, started almost 30 years ago and was started as the LSST Corporation to start and do this survey. Through a rich history, of which I'd be happy to talk details, um, that role has evolved to be more specifically to continue to support the science. It started with trying to raise money, getting money for the mirror. Key people contribute to that effort. Um, Construction was taken over by Aura, and they have built it, and we have started, and that is amazing. And so the Discovery Alliance, branded now as that, to emphasize that our mission is to support the science and the scientists, and largely through philanthropic contributions. Like we go and get money from other people. I don't have a lot of money um, to support the science, and I'll talk some about some of those programs and some about the future. So the idea is that anyone with a scientific question about the universe for which LSST data is relevant, right? Not like who's going to win the football game next week or whatever, right? But like some question about the universe involving science, someone should be able to answer. We have progress in science when all of people's questions, when people's questions can be answered, and that the barriers they have, they're given the tools to overcome them. Not like delivered on a silver platter kind of things, just here's the thing. Here's how you would learn how to do this. Here's how to do this thing. Here are other people interested, and creating a supportive network of doing that where people have the skills, are able to learn the skills, and have support in infrastructure and software and in compute and in community. And so that reflects in our focus areas of the programs we run. So there's the Link Frameworks, the Software Frameworks program, largely based at University of Washington and Carnegie Mellon University. That's been doing lots of key stuff, working on infrastructure for LSST, including, I'd say, this week, the HATS LSTB catalogs that are being released as a fast access way to do stuff is coming out of that effort. They've run a series of incubators where a scientist, a group with an idea said, here's the thing, or often, here's some code I wrote as a graduate student like 10 years ago, and now I kind of want it to work on like a billion records, and I don't really know how to do that. Can you help? And the answer is yes. And the answer is yes, we'd love to. So there have been incubator programs, several, I forget, 6. It's getting beyond my ability to count. I only have one hand free. And that's been super successful. We're happy to talk about details. We've had Project Dovetail, which is a little more targeted, which is a software engineer who loves astronomy, would like to talk to you, has 20 hours. How can they help you improve your code, or more often, help you think through what it is that you wanted to do? What's easier? Like, oh, here's just a solution, or here's how you want to think about it, or how do you want to do this? Starting this year and over these next few months, I'll talk about, we have supporting early science with LSST. I am super excited about. Of course, I'm excited about the data, but I'm excited about all the different programs that are supporting in that. We have larger scale postdoctoral programs. We have data science fellowship that's largely out of Northwestern now. Undergraduate summer program, Ryan Okers is here, looking sharp in his suit jacket, since he's enjoying being in California and not South Texas, which is a wonderful place. It's just a little warm. And the new Vera C. Rubin Frontiers Fellowship. You'll be seeing more about that in the next few months. And then community, doing things that no individual institution can do very well, like getting your institution to pay for childcare for you to go to a conference is basically impossible. Even if every person you talk to wants to make it happen, they just can't. They just institutionally can't. So that's an example of, it's not a huge amount of money that we've done. I mean, it's hundreds of thousands of dollars, but it's made a huge impact in people's ability to attend conferences. Expansion partnerships, welcoming colleges, welcoming places that aren't R1 universities, aren't doing all this stuff, because the entire point is that LSST is for everyone. Right? I spent time at Berkeley, I spent time at Harvard, we had telescope time, whatever, right? This is not for that. This is for the school that has a half meter out back that one person kind of knows how to use, and they have an undergraduate thing, and connecting them to everything. So I want to talk a little bit about the accelerating early science. So we've had two related, in some sense, prawls about early science. One was an early science by the Heising-Simons Foundation, very specifically. This was $850,000 total. And this is sort of distributed over this year. And each of them come with a support of software. We basically said, you just get a software engineer who's going to call you. You don't have to call them back. It's okay. But, reducing that barrier just to have that as part of the support. So there were 14 awards and 11 member institutions. So I should mention that the structure is we have member institutions. We have 40 institutions from around the world, mostly in the US, who contribute to make this happen because they believe in this mission. They believe that it is worth coming together to make this happen and making the science happen for everyone. You can see the full list of programs here. Relatedly, very specifically about data preview 2, and the early DP2 as part of the linked software frameworks. There is money specifically to have events. So we had a call and a rapid turnaround. We turned around in 2 weeks from the proposals, maybe less than that. And we are supporting 12 events across 5 continents for everyone, to try to get people to start with early data, with the early data DP2, and start doing science and start understanding that. And this is funding is coming from the Schmidt Sciences support, which funded the Link Frameworks Initiative. We have announced and shared those with everyone, but we haven't gotten people signing back and accepting on all of those. So we haven't publicly published the list. We're not trying to keep it secret, right? We just offered, but people haven't formally accepted. So it's not our place to write that list yet. So people may post about things, you may hear about things, and that's great and fantastic. And we'll totally advertise them once they start happening, and because they're going to start happening soon, right? DP2 started coming out yesterday. So I'm so excited to see the things about this and so excited about the reach we've had. The Vera C. Rubin Frontiers Fellowship. So this is going to be a 2-year postdoctoral fellowship. And this is through NVIDIA. And there's a collaboration agreement with Slack that's going to host some of the GPU hardware that NVIDIA is donating. And then it comes along with a person of a fellowship to doing research that would take advantage of that. But in the spirit of supporting the Vera C. Rubin LSST Science and Survey. And NVIDIA has their latest chip framework named after Vera Rubin, recognizing that. We have not put out the call for applications yet or the review panel. This is a quite serious, this is a community thing. If you are interested, please contact me, because you know me. If you don't, feel free to introduce me. Or specifically, Anna Gabella is organizing and running this for us. She works for us, but to do this. And particularly if you're a graduate student or sort of earlier in career, you may not know what your senior colleagues know. Things get determined by who shows up. So if you have thoughts about how this should be awarded, what the important science to start, I volunteered to be on the review panel or the committee to help do things. That's how you make influence, and that's how you learn things. It can be really useful. The first time I sat on an NSF review panel and I read 20 other excellent applications, I felt so much better about having been rejected the previous year. But it's very informative, and that's part of the process. The Project Dovetail, we've had individual engineers that we've done this with, software engineers. But we also wanted to announce that we're incorporating a new pathway from our Australian colleagues who have joined both Rubin LSST and the Discovery Alliance. And they're professional scientists through the ADAX. I'm sorry, I forget. Computing, astronomy, something. To have not just assorted engineers, but significant time from a few people where this is what they're doing and contributing their expertise. So Project Dovetail is going to involve sort of both of those things. And really it's, if you think you might want to just talk to someone, we are interested. I think it can be hard to articulate, oh, I need help because I need someone to help me solve this problem. If you're at that point, that's already great. But to be honest, like lots of times you're like, I'm just in office hours and I'm hoping to kind of learn maybe what other people are saying and asking, which is fine, right? Because that's just where you are. You don't have a question yet, almost even. You just know it's not working. we're totally happy to start at that level and make advances because the point is to remove the barriers for everyone. I love my colleagues who know how to use large databases and run Dask clusters and all that, and I love talking to them. And I'm not working very hard to help them because they're okay for looking at these large data sets. What makes a difference is if everyone can answer to ask their questions. So we have a variety of opportunities. We have a very complicated website. It has an apply button. If you want to apply, click apply. And I know this sounds silly, but all websites, right, cater to all different things, right? Even the Discovery Alliance website or the Rubin website, you know, are you a student? Are you someone who wants to do science? Are you media? I just wanted to give you a little orientation. We use submittable.com to handle all of our submissions because we are a small group. We are currently, the integral is less than 5 staff. There are like 6 people. So speaking of staff, so Beth Willman has been CEO for almost 4 years, and she has announced her a decision to, let's see, retire is not the word, step down, take a break for a year. She will be back doing some other great thing, but she is stepping down from being CEO of the Discovery Alliance. And just because this is recorded and I checked, I was going to say a few words and invite some thanks and applause, and I will send it to her just as a little clip later. She's on vacation right now because, you know, it's August. She has made incredible contributions, taking us fully realizing the transformation from a group that was thinking about construction, thinking about managing in-kind international contributions to what we are now, clearly focused on raising money from foundations, private philanthropy to support the science and the scientists. And her contributions have been amazing. Her ability to know the community has been fantastic. And it's been certainly a pleasure. And I have learned so much just being board chair, having her as CEO. So if you would be willing, in absentia, I would like to give her a round of applause. Thank you. I will pass that on. So we started a search, and we'll run a search for a long-term CEO. She let us know in April. She let us know in plenty of time. But still, it takes time to find someone, particularly for the vision and the reach of what we're looking for. So we will have a long-term CEO search. But in the meantime, we needed to have an interim CEO for the next 9 months, 12 months. So I'm very pleased to announce that we have secured and just signed a contract yesterday morning before this meeting for our new interim CEO, Richard Green. Richard, do you want to come up and say a few words? Richard has had many roles in the astronomical community and is known to, I think, many of you, former division director of astronomy for NSF, interim director of 2 different important activities, which is certainly exactly what we need, right? Someone who knows the context, but is willing to help us and understanding in this transition and change. Here, Richard, you want to say a few bits?
Thanks. Just a few bits. First of all, about Beth, what he said. These are enormous shoes to fill. And as I've become acquainted with the staff, I realize what an amazing visionary and team building person she has been in this job. So we have tremendous forward momentum because of Beth and her dedication. It's interesting times, right? The data are flowing. Sadly, the National Science Foundation is taking a step back from their support of basic research, and happily, rich people are feeling rich because of their portfolio. So it's a good moment to think about how private philanthropy can really make a difference here. So I'm looking forward to hearing from you as you start getting your virtual hands dirty with the data, what you need, what works well, what's missing. And if you could respond on the DA Slack saying, boy, if I had this tool, I would discover the following wonderful things, maybe we can help. So it's the aspiration of the board, as I understand from Michael, to be growing the contribution that we are able to make. And I look forward to helping that happen in this interim. So thanks.
Thank you, Richard. So Richard Green is our interim CEO. I wanted to introduce a couple new names you might just see around. I already mentioned Anna Gavella, who's going to be our special projects assistant. Gisela Perez is coming along to be our accountant. You probably won't hear from her, but I wanted to list these names because if you have some grant or something, you may see some of these different people. And then Susan Boatwright, who has been administrative assistant for a while, is now the executive coordinator, still helping the CEO and now the board as well. So these are just a few of the names to see. So we're going to have a long-term CEO search. This is an important and serious endeavor, and I specifically welcome your comments, your advice, your suggestions for this. I have 0 seconds left. Great. And we're going to start in August. We're looking at signing the contract with the search firm now. So please email me, talk to me, find me on the, as you keep hearing it, the LSST Discovery Alliance Slack. We run the Slack space. That's one of the things we provide for the community with your questions and suggestions. And I will end because I am much less important than all the fun lightning stories you hear. But the mission of the Discovery Alliance is really for everyone. And we are here, and please come talk to me. Thank you.
All right. Hello, everybody. If you don't know me, my name is Stephanie Deppa. I am the astronomy content strategist on the Rubin Education and Public Outreach team. And one of the things that we love doing during this workshop every year is organizing these lightning stories. These are short 5-minute, 3-slide talks that you'll hear from 4 of your colleagues. And this is just an opportunity to get to know a few people within the community a little bit better. And so we'll hear from 4 people today. Theo, Mia, Chris, and Jeff. And with that, I will invite Theo to come up first.
Okay. Hello, everyone. If we haven't met, my name is Theo Shutt. I'm a current grad student here at Stanford and SLAC for the next about 2 weeks. And then I will be going to Carnegie Mellon to be a postdoc researcher. And so, yeah, so I've been in Desk and also as part of Rubin since 2020, since about the beginning of my PhD. And so I wanted to go over kind of what the science I work on and how I've done that through Rubin. So the main science case that I work on is weak gravitational lensing. And so this graphic here shows kind of the concept here that we look at background galaxies that are embedded in the larger cosmic web of dark matter and ordinary matter. And then as their light propagates through the universe, it gets bent and distorted by the intermediating mass by general relativity. And if we look at their projected images and look at how aligned they become due to undergoing the same distortions, we can actually understand better the statistics of the matter distribution itself. And so that matter distribution is very much impacted by both the expansion of the universe, essentially dark energy now, as well as the gravitational attraction from matter. And so this is a very great probe of our kind of the cosmology and particularly dark energy. So I've worked on this mostly in my PhD in the dark energy survey. So I worked on the year 6 cosmology analysis and mostly focused on the point spread function modeling for this. So we have to measure, over 100 million galaxies shapes. And so understanding the contribution from the telescope, the atmosphere, the sensors is extremely key to getting the correct shape measurements. And so that's the work that I did in dark energy survey. And so now with the amazing new Rubin data coming out, I'm transitioning to working on weak lensing systematics with Rubin data in the dark energy science collaboration. So what I've been working on the Rubin side, I've kind of worked on it throughout my PhD, and it's really been kind of at the interface of Rubin and the desk. So here at SLAC, I've been part of the LSST camera team. So I've worked both on in-lab testing of the camera here at SLAC, and I also worked at the summit last year for 3 months doing on-sky commissioning. I've also been working since the start of the commissioning science units. I've been working in the point spread function modeling science unit, and that's particularly been useful. My background in dark energy survey, since we use the same software, the Rubin PSF modeling software is the same as what we used in DES. So it's this PSFs in the full field of view, or PIF, if you've heard of it. And then I've also been for about the past 9 months, also helping with the active optics commissioning. So this is kind of the autofocus of the Rubin of the telescope. And so that's kind of also been work for improving image quality for the survey. And then just a bit about me. So I have various hobbies that you're more than welcome to ask me about or chat with me about, both on like crafting with knitting and crochet, cycling, especially around here, which is a great place to do cycling, and hanging out with my cat. And then I wanted to just give a shout out for something that I've been pretty proud of to work on in my PhD. So I'm a co-founder of the CAIPAC Chile Engagement Program, which is based here at CAIPAC, where we fund CAIPAC members who are in Chile for research to visit Chilean research institutes to kind of build a greater connections between US and Chilean researchers in the astronomy community. So if you're at all interested in learning more about that or wanting to help host, please chat with me. So thanks.
All right. Hi, everyone. My name is Nia Delis Reyes. I use she, her pronouns, and I'm an assistant professor at Amherst College. So Amherst College is a small liberal arts college. It's an undergrad-focused institution, not to be confused with UMass Amherst, which is literally down the road, which is the actual R1 institution. So even though I'm at an undergrad-focused place, I still get to work a lot with undergrads and grad students and postdocs, not just from my own institution, but from UMass as well. I am a relatively newcomer to LSST. And I'm largely a science user. So my science interests are in dwarf galaxies, low mass things, mostly in the nearby universe. The tagline of my lab, which is called the BOBA Lab, which stands for Baby Objects with Baryons at Amherst, which is not convoluted at all. And I did not try really hard to make this work. Small galaxies, big questions is kind of our motto. We're interested in galaxies, dwarf galaxies in the near scales. So I'm actually a spectroscopist by training. Much of my PhD was spent looking at dwarf galaxies as resolved stellar systems. So I did a lot with individual stellar spectroscopy, doing galactic archaeology type things. And then over time, I realized there are only so many galaxies for which you can look at individual stars. And I was willing to sacrifice some spatial resolution to look at things slightly further away. So I got interested in sort of extreme dwarf galaxy populations, low mass galaxies located in extreme isolation in cosmic voids, things that might be hosting AGN, and using IFU data, so still spectroscopy, But over time, I've come to realize that if I sacrifice both spatial and spectral resolution, I can get even larger data sets. And so this is what brings me to LSST today. So I've been pretty excited about following up analogs of Milky Way satellites, right? So our local group is an n=1 sample of local groups. And it would be nice to compare with other local group type environments. And I'm also just generally interested with how well we can actually measure dwarf galaxy properties using integrated light. My path to LSST, as I said, is pretty short because it happened very recently. I kind of on a whim attended one of these early science with the LSST programs, which I think is supported in part by LSSTDA. So as Michael mentioned, there are various programs supported by philanthropic organizations like the Research Corporation for Scientific Advancement, which hosted these sort of weird Shark Tank type conferences. So you like show up and you have to pitch to a bunch of people with groups that you sort of get thrown together into. It was a fun time, and we ended up coming up with a couple of projects, which include things like trying to constrain reionization by looking at low mass dwarf galaxies using LSST, trying to look for the first binary dwarf AGN with LSST using time variation. And that has sort of led me to where I am today, which is I'm nominally in the Galaxy Science Collaboration. I think I mostly just lurk on the Slack, but I'm hoping to get a little more involved. And I'm in general really excited about trying to develop a catalog, a real statistical census of nearby low mass things with LSST, which is something we've never really had before. So if you're interested in any low mass, low redshift galaxy science, please feel free to come talk to me. And also my postdoc, Dr. Joy Bhattacharya. Joy, are you here? Joy's in the back, waving. If you want to say hi to either of us, we'd love to chat. And then just a little bit about me. I guess here's the requisites. This is my academic path. Perhaps the most interesting thing is that I was here as a postdoc. And this was one of my fondest memories of Stanford, was doing this Stanford radio dish hike. So if anyone is interested, I was thinking of going on Wednesday evening, sort of after the conference, to do this short 4-mile hike, if anyone would like to do it with me. I had never been, and then from Stanford, I came to Amherst, which was a huge new experience for me. I'd never been at a small liberal arts college before, but I really like my position. It's half-time research, half-time teaching, and also I'm on sabbatical. And so life is so good right now. So if you also want to chat about things that I could do on my sabbatical, I would be very happy to do that. Theo, maybe I can go to Chile. We can talk about that. Outside of astronomy, I guess still tangentially related, I am generally interested in trying to make astronomy and science accessible to everyone. So I was a longtime author for Astrobytes, and I'm still a huge fan of the Astrobytes collaboration. My family's from the Philippines, and so I've been getting more involved with this growing astrophysics space science program in the Philippines, which is very small, but steadily growing. I think we're sort of at a critical mass for there to be a real astro community in the Philippines. So if anyone is interested, Philippines, also a great place to travel. Please let me know, and I'm happy to put you in touch with potential collaborators. And then finally, I believe that the night sky is for everyone, and this is maybe a somewhat lukewarm take, but I do think that the names we use for things matter. And so the LMC and SMC have been named after someone who may not necessarily deserve having things named after him. I'm super happy to talk more about that if you're interested. I guess outside of astronomy, I like climbing. I like doing aerial silks. These are both things that I sort of picked up when I lived in California. And lately, I've been getting into making cakes for my students. So every time they submit a paper, every time one of my trainees submits a paper, I make a cake and decorate it to look like one of their plots. So if you want to collaborate with me, you too could get a cake. Thank you so much. It was so nice to meet everyone.
Good morning, everyone. If we haven't had the opportunity to meet yet, my name is Chris Hernandez. I go by Chris or Christopher. I'm a PhD candidate at the University of Pittsburgh, working with Michael Woodvasey. And I've been part of Rubin since I started my PhD. And here I have outlined some of the science collaborations that I'm a part of. Now, oh, did this skip us? Maybe they're not in the right order. Okay. Anyways, my journey started in the East Bay in California. I'm from the city of Richmond. I was born in Berkeley and grew up in Richmond, California. And I did my undergrad over at UCLA. I had the chance to move out of the Bay Area, meet a larger community of astronomers, a larger community of people, and expand what my world had been until I was the age of 17. When I graduated from UCLA, I then moved over to Pittsburgh, Pennsylvania, which was quite a shift for me because it gave me the opportunity to once again expand my world and meet people from different walks of life. And ever since I've been in Pittsburgh, I've been interested in uh, transient characterization here in the era of Rubin. And I'm currently working on 2 different projects that explore transient events such as supernovae and also curating a sample of variable stars to analyze their properties and better understand the evolution of our galaxy. Now, all of this has been a result of the work that I've done in part of the Pitt Google Alert Broker. There's a session happening tomorrow that talks a little bit more about brokers. But if you are unaware, a broker is essentially a software that is designed to ingest, process, and distribute alert data from Rubin to the entire world. And so when I joined the University of Pittsburgh, my work was to prepare the broker for LSST. So since late 2020, the Pitt Google Alert Broker has been ingesting alert data from ZTF, and now that has grown to multiple other surveys. And as you can see, and may be well aware of, LSST is going to produce a flood of data. And so it's very important to create resources for people to be able to easily interact and access that data. And so the Google in Pitt Google is actually a representation of our adoption of Google Cloud services to the issues our field is currently facing. So by combining these techniques with external data products, such as catalogs from other surveys that span a variety of different signals, we can paint a bigger picture with all of the information that Rubin LSST will produce. And then lastly, a little bit about me. I'm very passionate about a lot of things. And one of the main things that I'm passionate about is developing community and being aware of how I navigate spaces in different communities and how these communities interact within each other and with other communities. So while I was at UCLA, I founded an organization called AHEM, which stands for the Advancement of Historically Excluded Minorities. Now that I'm currently in Pittsburgh, I also helped found another organization called DAC, Direct Action Coalition. All of this to say that I really care about the lived experiences of the people that I interact with. One of the things that DAC has been monumental for is getting a better sense of what the lived experiences are in our departments. So through DAC, we've now had annual town halls where we learn more about what people are living through, what are the challenges they're facing, and DAC helps provide solutions to those issues that people are experiencing. I'm a big public transit nerd. I love talking about public transit. One, because I think that it can significantly improve the quality of life. I think having access to public transit can really make a difference. And then lastly, I care a lot about land stewardship. I think that we should protect the single planet with known life, and we should continue to protect the resources that can sustain life here on Earth. So thank you. If you'd like to connect with me, scan the QR code below.
Hi, everyone. My name is Jeff Innes. I am on the Rubin EPO team as a senior software engineer. I just joined the team in January of this year. So I just want to tell you a little bit about my journey to Rubin. It starts back in the 1900s. I was born in Tucson, Arizona. Growing up, I was fed a lot of Bill Nye the Science Guy, Carl Sagan's Cosmos, Nova, and my stepdad worked on the Gong project at NOAO. So I actually got to pal around the NOAO offices a lot as a kid and just like hear people talk about cool stuff. I got a lot of exclusive tours of Kitt Peak, which I later found out as an adult, you can just book these tours. They're not actually that special, but I didn't know that as a kid. So it was really cool for me. But I never actually saw a pathway into astronomy as a career. Instead, I wanted to make video games, as many 90s kids did. But it turns out, as I got into college, video games are not just like making video games. There's a lot that goes into it. And while I liked programming, I was actually just really passionate about storytelling and world building. So I became a dungeon master in D&D instead. And spun my wheels in college for a bit. And as about half of us at Eller did, we kind of didn't know what we wanted to do, so we got business degrees. My professors would not be happy with these slides, by the way. But yeah, so I did that, graduated from Eller, and then I went to work at Buffalo Exchange, which is a fashion clothing resale company. Worked in their IT department though, so got my hands on more tech. While I was there, I also got into programming again. I just couldn't get away from it. And I built out an internal development team to build solutions for internal problems they were having. So I did that for about 11 years. I roughly did the math on that for you. Yeah, and then one day I was just on LinkedIn and a position came across to join Rubin. And I kind of saw this confluence of all these things I was passionate about and interested in, threw my hat in the ring. And here I am in front of you all today. So on the EPO team as a developer, my role is mostly supporting our team's various efforts like the main website, troubleshooting bugs recently, that happens, helping build out new features, working on Skyviewer and Orbit Viewer, which are really cool, fun technologies. If you have not explored those, please do so. They're a lot of fun to work on. And I was helping build out the hazardous asteroids investigation with the education team, which was a lot of fun. I even learned a bit about hazardous asteroids. Not the math part, though, that was all confusing, but the 3D representation of things is really cool. And I'm also going to start working on the citizen science pipeline. So that's probably where we'll be interacting as we go through. Then just a couple things about me. Should you wish to strike up a conversation, I own a cloak and I am part of a movement to bring them back into fashion. I have it here with me, but it's been actually a little bit too warm to wear it. But if enough of you ping me on Slack, I promise I'll break it out. This might be a shock, but I think about Lord of the Rings a lot. And if you ever want to just open with a Lord of the Rings meme, I promise I will not get tired of it, even if I've seen it a million times. And something else that I'm actually really passionate about is making like community spaces. I really like connecting with people. So a couple years ago, I started a meetup for developers in Tucson. It's been kind of a dark couple of years for the developer industry, AI and like COVID breaking everything up. So trying to bring that back, it's a struggle. But if you also want to start community things and you want to hear about it from the trenches or not make the same mistakes I did with social media, yeah, I'd be happy to chat about that. And I have a QR code up there. You can connect or just find me around, possibly in my cloak. Yeah. Oh, yeah, that's it for me. Thank you.
Hi, good morning, everybody. My name is Ryan Oakers. I run the student undergraduate program for the Discovery Alliance. I feel like I should quickly respond to Michael and just say that the temperature is below 95. And my mom always said, if you don't want to catch a cold when it's cold, you put a jacket on. So that is what I'm doing. So while the students get up, yeah, perfect. I will just quickly tell you that you're going to be hearing a bunch of 30-second pitches from a bunch of the posters today. The poster sessions, I want to remind you, are from 3 to 3:30 every day, Monday, Tuesday, Wednesday, and Thursday in Building 53. So please check them out. 15 of the students specifically that you're going to be hearing from today were supported by the Discovery Alliance to come here. These include several students from some of our international organizations. The program that we run includes things like tours of museums, as well as coordinating different career breakout sessions for the students to participate in so they can learn about how to stay in astronomy and learn what professional astronomers do. I won't take up any more of your time. I'm sort of stalling while the students get in their order. But if you have questions about the student program, you'd like to talk to me about how your students could get involved, please let me know. as we sort of progress through the survey, we're going to have more and more students working on Rubin, as we've seen sort of even in the RCW over the years. So if you'd like to talk to me at any point, please just find me and I'd be happy to talk to you. So without further ado, we'll let the students come up. So if the first group wants to come up.
Our group is, oh, wow. Our group is working on using a photometric and imaging data to find galaxy morphology. So see here in our image, you can see we're able to find galaxies within a cluster, isolate those galaxies, and then use Surzic models to find the features of those galaxies. Interesting thing that we're doing is using LST and Euclid data as a cross-matching reference. And so if you want to learn more about that, come visit us. We'd love to talk to you about it. And thank you.
Hi, I'm Narain from Penn State, and my poster discusses detecting offset AGN using ZTF imaging and machine learning classifiers like ALERS, and then replicating similar methods with Rubin data. So we currently have 7 candidates, but we're hoping to get a lot more with Rubin imaging. So yeah, come check out my poster for
Hello, my name is Ali Baldelli. I'm a first-year graduate student at the University of Delaware, working with Federica Bianco, and my work is fine-tuning an attention-based classifier for supernova spectra, specifically working with low-resolution spectra. I'm working on expanding its abilities as well as comparing it to other popular classifiers. As you can see from our preliminary results, we're doing pretty good so far. But I'd be happy to talk to you more about how we're expanding that and what the model is like. So come talk to me at the poster session tomorrow and Thursday.
Hello, my name is Ian Beard, and I'm a rising senior at San Diego State University. My research focuses on a rare and peculiar type of type 1a supernova, which is called the 1ax subclass. Prior research has shown that the expansion velocity of these supernovae, which is an important metric in determining the kinetic energy of the explosion, is much more difficult to measure in type 1ax supernovae than type 1as. In my research, I'm using the spectral synthesis code called TARDIS to model the optical spectra of these supernovae in an effort to properly measure the photospheric velocity. I look forward to seeing you in my poster, and let me know if you have any questions. Thank you.
Hello, everyone. My name is Sam Critchley. I am an undergrad at Stanford, and I work with Shunsheng Li and Aaron Rudman. I'm working on quantifying PSF uncertainties, point spread function uncertainties, using stellar shear response measurements, which will help with some weak lensing analysis, help quantify some systematic uncertainties. And if you're interested, we've found some pretty cool results so far with simulations. So come check out my poster today at 3 p.m.
Hi, everyone. My name is Grace Davis. I work with Charlotte Ward at Penn State, and we're working on discovering changing look AGN through multi-survey photometric and spectroscopic data, including SDSS, DESI, ZTF, and now Rubin. Through this, we've found 2 changing look AGN, and we have 9 candidates. The plot up here is the photometry of one of our changing look AGN, and you can see around 2021, it turns on. And so we're working towards finding more of these changing look AGN with more Rubin data. Come visit me to see my poster and learn more about changing look AGN. Thank you.
Hi, everyone. I'm Russell Dunlap from the Penn State University, and I'm working with Professor Charlotte Ward. I'm using machine learning algorithms to help classify and characterize the host galaxies of transients. And specifically, I've been looking at a lot of data preview 1 data, and I'm classifying these galaxies based on color-dependent morphology. And so there's some preliminary results. I've been using 3 different type of morphology metrics. And so you can see the initial data classifications of the DP1 data, and then also some of the first machine learning clustering. And hopefully next we're going to be using magnitude and also some other color bands, and hopefully also integrating Euclid into the data in the future. Thank you.
Hi, everyone. My name is Constanza Gomez, and I'm a Intelligent Systems Engineering undergraduate student at the UASLP in Mexico. A little bit different from physics and astronomy, but my project focuses on how different machine learning algorithms can classify periodic variable stars using the extended LSST astronomical time series classification challenge, or elastic dataset. So if you're interested in any of that, please come talk to me at my poster.
Hi, everyone. My name is Reed Hammer, and I'm a rising junior here at Stanford University. And my research question was, in real data, how observable are the stellar streams of tidally disrupting Milky Way dwarf galaxies? And so I used simulated mock dwarf galaxies to compare the tidal disruption of of stars that we'd be able to observe with the entire mock dwarf galaxy down to stars that are much too faint to see. And then I plotted density profiles along and perpendicular to the orbital direction of motion to evaluate the tidal disruption. And if you'd like to learn more, come find me at my poster.
Hi, I'm Theo Hobner from Stanford Online High School. This is my mentor, Kalei Talk. We set out to replicate Choi et al. 2025's a study which used Rubin DP1 data to find the amount of member stars in the 47 Tucani globular cluster. We used color cuts, isochrone data, and Gaia DR3 proper motion to find this value, and we ended up with an overlap of about 89% with Choi et al.'s final data set. Please swing by our poster if you want to learn more.
Hello, everyone. My name is Marnie Hernandez, and I recently graduated from Cal Poly Pomona. My advisor was Dr. Brianna Binder, and we mainly did science on the outskirts of 47 Tuc. My portion of the project was seeing what Rubin variability metrics would help us identify potential variable star candidates. And we used the Chandra source catalog for the X-ray components and Rubin's DP1 for the optical components. And we cross-matched 91 potential candidates. And from those 91, I went ahead and used the variability metrics and was able to bring it down to 34 potential candidates. And we proposed classifications for some of them.
Hi, I am Guinevere Heron. I use she, her pronouns, and I am a rising fourth-year graduate student at Dartmouth College working with Bershan Mutlupak-Deal, who is here today. I work on using AI to identify low surface brightness galaxies in astronomical surveys. In a couple months, we'll be publishing a catalog of LSVGs in DES Year 6, where we found 32,000 of these galaxies, around 5,000 of which were novel detections. We also show some of the joint distributions, which we completeness correct using simulated LSVGs. My poster will be up on Wednesday and Thursday, and I highly recommend stopping by. Thank you.
Hi, my name is Maeve Jack, but y'all can just call me MJ. I know the BH is a little scary, but no. Okay, well, I worked on linking UV light curves to AGN accretion disk turbulence with Dr. Amy Secunda at the Museum of Natural History. And I attempted to put a video, since posters can't have videos, so y'all could see the changes in disk fluctuations. So if you would like to see whatever that figure was, come to my poster.
Hello, my name is Jamar Kidling. I'm a grad student here at Stanford University. I work with Aaron Rudman, mostly on weak lensing. Weak lensing measures shear mostly by calculating this response matrix, but if our PSF model is off, this contributes to a residual in response that can manifest as a bias in our measurement. I basically try to see or measure how this response depends on our PSF model errors. And you can see that's approximately linear. There's more details on my poster.
Hello, my name is Henry. I'm an undergrad at Rutgers University. I am working with Josh Cable and Erica Weiser. And so my research focuses on if comparing an LSST year one like simulated sample of galaxies with CMB lensing can help improve our constraints on dark energy. So the plots over there are some cross power spectra between galaxy density and CMB convergence, just some basic results. And then if you want to learn more, come check out my poster.
Hello, my name is Yusma. I actually work with Henry and under Josh Cable and Eric Weiser at Rutgers. And my poster is looking at if combining Lyman break galaxy observations with the CMB lensing measurements can improve constraints on dark energy. So I have two figures. One is a redshift distribution of the galaxies we're looking at, and the second one is a LBG CMB lensing cross correlation power spectra. So as everybody has been saying, if you want to learn more, come to my poster to find out.
Hi, my name is Jinshuo Zhang from the University of Washington, together with Nirav Mali and Professor Joko. We make a probabilistic star galaxy separation model, and then it has a better performance than the Rubin binary extendedness flag.
So our probabilistic star galaxy separation model actually allows us to combine probabilities across different bands to get even better results, and allows users to set their own thresholds depending on what kind of purity and completeness they want. If you want to learn more about how our model works, come visit us at our poster tonight.
Hello, everybody. I'm Matilda Nilsson. I'm a PhD student at the University of Delaware working with Federica Bianco. And so what I'm interested in is finding which transients are interesting quickly. And so to do that, the plot I have here is just a slice of a color versus magnitude change data cube, where the other dimensions include time intervals between color and magnitude change measurements, and then also the filters used. So this is 6 transients from DP1 plotted in this space. And this is a crop graph. If you want to see the full thing and learn how what I did actually matters to the research question I have up here, come find me at my poster. I'll be presenting Wednesday and Thursday.
Hi, I'm Shivam Panda. I'm working with Wenfei Fong and Nick Vieira at Northwestern. And we've been working on a project called Trove, which essentially scores electromagnetic counterparts to binary neutron star mergers and other GW events. And specifically, I've been working on the distance scoring and creating a hybrid metric to accurately score photometric and spectroscopic distance measurements. So those are some plots, and I can explain more at my poster this afternoon. Thank you.
Hello, my name is Alondra, and this is Antoine, and we are both undergraduate students at San Diego State University. This summer, we have been working to try to find the cause of the formation of the young stellar population within the Fornax spheroidal dwarf galaxy, and we have combined Rubin DP1 data along with Hubble and Stetson data to create a master catalog of the youngest stars within this galaxy, and we hope to use this catalog to try to answer our questions. So please stop by our poster today.
Hello, I'm Maya Redden. I'm a graduate student here at Stanford. I work with Patricia Burkett. I'm looking at all things differential chromatic refraction, or DCR, specifically looking at its impacts on our ability to do good astrometry and good PSF modeling, and also maybe using it for new science, because the atmosphere is kind of like a really bad spectrograph. So if anyone wants to learn more about this or already knows a lot and wants to critique me, I'd be happy to talk to you at my poster tomorrow or Thursday.
Good morning. My name is Ania Rosales. I'm a rising sophomore at the University of Texas Rio Grande Valley. My research is on cataclysmic variables, which are cannibalistic binary systems where a white dwarf stirs the mass from a companion star. I'm using the LSST alerts to catch the sudden violent brightness flare-ups. This is very important because many astrophysics models predict that these should be everywhere, but they're very faint to catch. This is really important for us to learn and understand the evolution of the systems. If you have any questions, feel free to come to my poster. Thank you.
Good morning, everyone. My name is Leo Sykoff. I am a first-year graduate student here at Stanford, and I work on cosmology with Lyman-Break galaxies, which we'll hear about from Ben. But my question right now is, can we use deep many-band photometric redshifts to estimate photometric redshifts for a shallower sample? And so I've done this for a simulated LSST sample, and I've looked at synergies with photometry from Roman and the HSC NIGI survey. If you're curious about how this works and its implementation as a modular pipeline in the desk Rail package, please come see my poster tomorrow and Thursday. Thank you all.
Hello, I'm Ben. I'm a second-year PhD student with Josh here at Stanford. And yeah, I'm interested in Lyman break galaxies. So these are these high redshift galaxies that LSST is going to detect tons of them. And the real benefit here is that they're at high redshift. So you can cross-correlate with CMB lensing and get a independent lever arm on a lot of the big questions in cosmology right now, like dynamical dark energy or neutrino masses. So I think it's the way of the future, and DESI 2 is targeting it. So there's a lot of opportunity in the next 5 or 10 years.
Hello, everyone. My name is Malika. I just finished my freshman year at Northwestern, and I'm studying extreme nuclear transients, or ENTs, which are a recently discovered class of transients that are the most luminous and most energetic that we've found in the universe. There are only 7 known ENTs right now, and I'm analyzing them over a broad range of wavelengths from 0.7 to 5 microns using data from SphereX. And I am comparing these spectra with that of quasar and galaxy templates to better understand the physical properties of ENTs, which will allow us to use LSST to our advantage to increase this population of ENTs and really learn more about these really fascinating transients. So I hope to see you later at my poster this afternoon.
Hi, I'm Devanshi, and I'm a rising senior at the University of Washington working with Jelko Evazic and Mario Juric. And we're building a Bayesian classifier to estimate the probability of an asteroid spotted by LSST on being a near-Earth object using just the motion of its single night tracklet. We plan on generating nightly ranked lists for the community to decide which candidates are worth spending their telescope time on. Come check out my poster later today if you want to learn more.
Hello, everyone. My name is Victoria. I just finished my third year at Adam Mickiewicz University in Poznań, Poland. And lately, I've been working on reanalyzing the asteroid data from Rubin First Look, focusing on the rotational periods. So if you want to talk about that, please come see me at my poster.
Hi, my name is Rona Zhang. I'm a rising senior at City Tech, mentored by Professor Charlotte Welker and supported by the ASTROCOM NYC program. And my research is on the classification of small-scale dwarf hosting cosmic filaments using the New Horizons simulation. We found good agreement between the hierarchical clustering and k-means clustering methods on there being 4 different types of small-scale filaments that cluster strongly around their hydrodynamic profiles. And we found that the star formation histories of one of the types of filaments matches something we found in observation. So if you'd like to learn more, please come talk to me at my poster.
All right, well, let's thank all the students one more time. So just a reminder, the poster session is in the afternoon during the coffee break, and I think that's it for the plenary. So thank you all for coming, and have a good conference.